Hello everyone, myself Dr. Kiran A Thabaj from KLS Gogte Institute of Technology, Belagavi. Today we're going to discuss how to tackle Karnataka CET and Comet K exams. In this, mainly we'll focus on what should be the approach, what should be the preparation required, and where you need to focus more. In this, we also discuss how to use a concept and how to apply them in more fruitful manner. Usually we are seeing that students starts organic chemistry by asking how and why these reactions occur, right? But this organic chemistry, initially we should ask only how these reactions takes place, only we should follow the mechanism of this organic chemistry, whereas why is always needs to a more confusion, it creates problems. So my advice is just focus on how these reactions occur rather than why these reactions are occurring. In this, we are going to focus mainly on alcohols, phenols, and ethers. Right? We know that these alcohols contains the OH group. Right? The molecules containing OH groups are known as alcohols, and the IUPAC secondary suffix is OL, that is propane, 1-ol, methanol, ethanol, those things. You can see the structure here. So OH group attached to a molecule is known as a propane, 1-ol, and these alcohols are classified on different criteria, like how many OH groups attached to a molecule. If only one OH group attached to a molecule, it is known as a monohydric alcohol. If more than one OH groups are attached to a molecule, it is known as a polyhydric alcohol. Again, these alcohols are classified based upon the carbon to which alcohol is attached to how many other carbons, right? Like we have primary alcohols, also known as a 1-degree alcohol, secondary alcohols, also known as 2-degree alcohol. Similarly, we have tertiary alcohols, also known as 3-degree alcohol. A primary alcohol is the one in which the carbon with which OH is attached is also attached to only a single carbon. The secondary alcohol is the one in which the OH group attached carbon is attached to 2 more carbons. Similarly, for tertiary alcohols, the OH group's attached carbon is attached to 3 carbons. Right? As I discussed, the polyhydric alcohol, in which we have more than one OH group. For example, we have ethane 1,2-diol, we have propane 1,2,3-triol, ethylene glycol, dietric alcohol, like that. Again, these alcohols are classified as allylic alcohol and vinylic alcohol. The allylic alcohol is the one in which the OH group with the carbon attached to a double bonded carbon atom, whereas a vinylic alcohol is the one in which OH group attached to a double bonded carbon atom directly. Right? Now, these concepts can be easily understand by solving the questions, right? Now it means that we are going to start understanding this concept by using a problems given in exams. Right? We'll start with the first one. Consider the following reaction. The unit reaction here now, we have a phenol which react with a zinc dust, gives rise to X molecule. The product is X. Again, this X product react in presence of or with CH3Cl chloroform and anhydride AlCl. Right? Again, this gives rise to one more product, that is Y. Right? Y again react with the alkaline KMNO4, gives rise to Z. Right? Now, question is that what is Z? But unless and until we know what is Y, we cannot determine Z, and unless and until we know what is X, we cannot determine Y. And each reaction give a different reagents. And we should, before we solving these type of questions, because these are the commonly asked questions. Most time they ask these types of questions. To solving these type of question, you should know what are the reagents used and what are their roles. Unless until you know what are the roles of those reagents, we cannot determine the end product. For example, in this case, the first one, phenol react with the zinc dust. Now, why zinc dust is used? Zinc dust is known as a reducing agent. That indicates that in this case zinc dust reduces phenol. When phenol is reduced by zinc dust, we get a benzene. right? In this case, you can see that the phenol gets converted into a phenoxide ion, and a proton thus release accept an electron from zinc, forming a hydrogen radical. Also, because of the heating, right, there is a homolytic fusion of carbon of phenyl ring and oxygen, right, that gives rise to a zinc oxide and a benzene. So X is now benzene. Now benzene react with the one more reagent, that is CH3Cl in presence of anhydride AlCl. Now this is a common reagent we used, the name reaction, right? Just think, this is a name reaction, right, in which alkylation takes place, right? This is Friedel-Crafts alkylation reaction. It means that in this case you're going to alkylate benzene. When benzene is alkylated, you're going to get a toluene. So why is a toluene? It's a toluene, right? Then why, right, react with the alkaline KMnO4? When you think of KMnO4, right, it's a strong oxidizing agent in presence of alkaline medium. That means that in this case the produced toluene undergo oxidation to give a acid, right? In this case you can see that the four options are given: benzaldehyde, benzoic acid, benzene and toluene, and the end product is acid. You're going to get a benzoic acid. The phenol zinc test gives rise to benzene, right? And then Friedel-Crafts alkylation gives a toluene, then oxidation by KMnO4 gives a benzoic acid. This is how you should solve these problems now. The next question is, what is the bond angle value of a COH in alcohol? Right. They are given four options here. One is 109 degree 28 minutes, 108 degree 5 minutes, 110 degree 111 degree 7 minutes. Right. Now whenever you think of COH, right, COH, the alcohols have a sp3 hybridization, and the bond angle can be easily checked with its hybridization as well as the structure. Now these alcohols sp3 hybridize, so for they have a tetrahedral angle, and we know that the tetrahedral angle is 109 degree 28 minutes. Usually students think that just tick this A as the answer, but it is wrong. In this case, even though these alcohols have a tetrahedral angle, sp3 hybridized one, but it contains a oxygen OH group, whereas the two lone pairs of electron on oxygen atoms, this pair pushes the CO bond closer to each other, that reduces the bond angle. This case now reduced bond angle is 108 degree 5 minutes. Therefore answer is 108 degree 5 minutes. Right? Look for next question quickly. What is a product obtained due to oxidation of primary alcohol in presence of H2CrO4? It is well known, a mild oxidizing agent, that is chromic acid. It's not a strong oxidizing agent. We are going to oxidize this one, oxidize the primary alcohol by using the mild acid, right? We know that whenever primary alcohol gives aldehyde after oxidation, the secondary alcohol gives ketone after oxidation. But if oxidizing agent is very strong, then aldehyde may undergo further oxidation to give acid. In this case, four options given are secondary alcohol, aldehyde, ketone, and all of those, right? In this case, this is a mild oxidizing agent. The answer should be B. It's a aldehyde. This indicates that if you want to solve any problem, you should know what the reagents are used in that. If you know the reagents used in that, you can easily solve these problems without any hindrance, right? In next video, we'll concentrate on few more problems, a few more questions, and we'll try to understand this organic chemistry more clearly. Thank you.